Machine learning is a study that gives computers the ability to learn without being explicitly programmed. In that long ago, programmers used to, of course, program computers on how to carry out various tasks. But recently, the current era, we see that the computers are made to learn from the data, and with time they are able to make what informed decisions. So the main idea is to access data, learn from that data, and of course make informed decisions on the unseen data or on data sets. Here we are going to look at the types of machine learning. So we have different two types, that is supervised learning, supervised learning. In supervised learning, the model of course learns from a labeled data set where the data is labeled by a human being. For example, we may give a model, we may be doing with images, maybe of cats and dogs. So in supervised learning, these images labeled, they be labeled as cats and dogs, and in such the models are able to learn these labeled images. Then for unsupervised learning, because the models will be fed with the images but or without the labels. Then we are going deeper into supervised learning. We shall see that to include both inputs and then the corresponding outputs. Of course, the algorithm learns a function, of course, that maps inputs to outputs, converting the input features to their corresponding output features. The major purpose, of course, is to make an accurate prediction on new and unseen data. Here, of course, humans come in and contribute some sort of effort where we do the labeling such that the models are able to what? Learn from the labels. We are going under supervised learning, given two types where we have classification and prediction. Under classification, you see that we deal with basically categorical data where we make predictions with categorical data. With categorical data, you look at examples like gender, where we have the group that are into male or female when we're dealing with things. We also look at blood groups. Of course, your blood group will be A. You also blood group O, like that. Then with the depression, we of course deal with medical sort of data. For example, physical metrics like weight, height, these are of course in medical form. Some of the examples of supervised learning algorithms, we have the 10 nearest neighbors, we have the decision trees, we have random forest, we have SVM, which of course fully support vector machines. Then we have logistic regression, we have neural networks. So coming into merits and demerits of supervised learning, we shall see that we make more accurate predictions when good label data is available. Because as you know, human error may come in when labeling these data sets. So there's also clear objective and measured performance as a merit for this. Then coming under the demerits, we are going to look at may not of course generalize well. The training data is of course biased. Then may also require labeled data, hence which really consumes a lot of time. Of course, you're going to maybe going over a data set of images and you having to label all these images, it of course takes some sort of human effort, hence consuming a lot of time. Then going for unsupervised learning, of course, this I had said prior that of course this deals with unlabeled data. So the data used here, of course, not labeled and of course not having what we call the target output. Here we shall see that the algorithm itself will explore data structures independently and be able to find hidden patterns or groupings in the data. So this unsupervised learning is useful places where labels may be expensive or may not be available. So some of the types of unsupervised learning, see, we have discovered that clustering is one of them. Dimensionality reduction is also another one. Then association rule learning. With clustering, I talk about you being able to put data in smaller groups. For example, decide to give customers using on their maybe consuming habits, how they buy the products. Then dimensionality reduction, we are looking at you being able to reduce features while preserving information. One of the algorithms here, of course, we shall look at the principal component analysis. Then for, for the other one, an example is market basket analysis, where we first look at discovering relationships. Some, of course, the algorithms here, we have the K-means algorithm, one of those algorithms that is used in supervised learning. We also have hierarchical clustering. We have the principal component analysis, also in short known as PCA. So going into the merits and limits of unsupervised learning, we are going to see that no need for label data is actually coming in as merit, because the previous slide I talked about this need for labeling data taking up a lot of effort and time. Then you can also, by the fact that the model is able to discover hidden patterns or groupings in the data that might not be discovered by a human being, is also a merit. Then the demerit, the other side, we see that results can be harder to interpret and validate. Remember these ones that have been, the model has learned things on its own. Then there's less accurate for prediction tests. So here I'm going to look at the 10 nearest neighbor concept. And of course I'll go over summary faster, where I'm going to talk about parametric and then non-parametric models. And so with parametric, I mean where of course you know the model exactly. Then for the other side of non-parametric is that the data tells you what the regression is or what the regression looks like. So going just an overview, we are going to see that the KNN, of course, is a non-parametric algorithm which of course the data shall be dealing with tells us what the regression is. And it's also a first choice when there is no prior knowledge, when you of course don't know much about the data. And an advantage of this algorithm, of course, is that it can be used for both regression and classification tasks. Because meaning you will be dealing with the continuous variable there and of course categorical variable the outside. Yeah, so we are coming to the an example, the video you had the Irish data set. So that's a summary of the Irish data set. Of course, this is, we see that it was a multi-class data set and it was bearing, of course, several features, 4 of them, where we had sampling, petrol weed, and just a breakdown of the remaining steps of the KNN. The calculate distance between all the training data and the test points. Then after we find the nearest neighbors for this, and then shall then classify these points based on majority vote. So still in KNN, we are going to look at the distance matrix and then the hyperparameter tuning. So distance matrix shall see that you of course use Euclidean distance when you're dealing with similar property. So provided you're dealing with these similar properties, you have to use the Manhattan distance. Yeah, so then point to note is where when the features are of course not of the same scale, you'll be required to do some sort of feature normalization for you to use this KNN property. Another key term under this KNN was the hyperparameter tuning. So you have to take in note that when you're going to do a hyperparameter tuning, it should never be done on the test data. Why? Because the goal is for us to perform well on what? Unseen data or the new data. Then also the careful cross validation, we have to split data into K groups. Then after you take the test data, you use all the data. So just to quickly go over the use cases of KNN and their pros and cons. So you see that KNN is applied in both sides. So cargo competitions, we see finance, we see agriculture, text mining, then this of course advantages. It is easy to explain as from the merits, then there are no assumptions on data distribution. So it's also under multi-class. The disadvantage is that efficiency declines as data set grows. The bigger the data set, was efficiency reduces. Expensive prediction steps. You also suffer from skilled class distributions cannot handle missing values. Then we are going to look at decision trees. We are going to look at terms like Gini, that entropy, and then information gain. So Gini impurity, we shall see that this basically this is measuring of frequency mislabeling. So it takes up values between the range of 0 and 0.5. Then the entropy on the other side measures the process disorder, and this value go from course a bigger range, 0.0 to 1. Now, of course, you'll see that the entropy, given the fact that makes use of logarithms, is of course complex. Then information gain is of course is biased for attributes with many outcomes. Those is distinctive values. So the terms here are coming in where we're having pre-pruning, post-pruning. So with post-pruning, you have to stop growth early, specify maximum depth, minimum sample split. Then of course we shall take note that pre-pruning alone is risky. Perfect split might follow, worthless split. So have to note of that. So decision trees pros and cons, you see that under pros it is easy to interpret, of course. It is non-parametric. It's non-parametric, we mean the data. There is what the regression looks like, and it is able to capture non-linear patterns. It also handles binary, the categorical and stroke continuous data. And on the other side, that is not sensitive to the algorithm is not sensitive to noisy data. Here we see that it might be result into overfitting. Small variations change the tree. Biased with balanced data, was algorithm some sort of Here we're going to look at ensemble learning, bootstrap, and then bagging in terms we are going to do. So ensemble learning, buying many yoke with models into one supreme model. With bootstrap, we are going to address, of course, challenges of estimating population information sample. Then bagging, we see that we get different models using bootstrap training sets and then average prediction. It improves accuracy at the expense of interpretability. Then random forest and boosting. Random forest is, of course, a collection of decorrelated features for each split. It is a process where subsample examples randomly pick features from each split. And the pros, of course, we have it is, of course, robust outliers so that is not affected to the outliers. It lowers overfitting risk. Then cons is biased with categorical variables, slow training. Then now we are looking at bagging versus boosting. Boosting is, of course, a sequential one. Sequential tree growing with a weighted sample. On the other side, the bagging parallel boosting, which is sequential. This one is parallel tree growing with upsamples. Then coming to my key takeaways from the machine learning diploma videos never tune hyperparameters using the test data set. Why? Because we want the algorithm to perform well on what? You seeing data. The non-parametric models data tells you what regression looks like. Any ultimate goal, of course, perform well on unseen data. Then also realize that KNN does not have 5 steps, it has 8 steps. So, and those were some of the study tips. Thank you for listening.